I recently saw this video talking about something called orthogonal design, and I thought to do a follow-up video to it. Not because it had anything wrong with it or anything like that. As I was watching the video, there was a lot I thought I could add to expand on a lot of the concepts that are mentioned in the video to get some behind-the-scenes explanation to these design dynamics and to share how this concept is useful in other design fields outside of game design, like architecture and product design. After deciding to do this follow-up video, I grabbed my iPad and saw all the supplemental materials Steve recommended, like the GDC videos and other documents, to have the full picture of where he was coming from. The gist of the video is that by making game components that belong to the same category as different as possible, rather than just having minute, hard to decipher differences between them, the game experience is easier to decipher and therefore navigate and enjoy. Then, Steve goes on to provide various game design examples. He touches on a theoretical scenario where a game has mechanics based on transportation vehicles. A game that offers 3 types of cars with 3 slightly different abilities is not as clear to the player as 3 totally different vehicle types, like one that provides terrain transportation, the car, another that lets you navigate the waters, a boat, and another lets you take to the skies, an aircraft. Here the abilities are different enough that it is very easy to remember and understand what each one does, rather than remember that 0.02% buff on speed if you choose the right color variation of the car. In this particular case, the silhouettes of each vehicle are so different from each other, the car, the boat, and aircraft, that it is easier for the human brain to identify them, categorize them, and remember them. This is why the creation of well-crafted silhouette is a pillar of good character design. Another example that he touches on is the enemy designs of Doom. How each character has a unique, discernible combination of speed, whether they stay back and attack you from afar, or how fast they charge towards you to attack, and their type of attack, whether they have a hit scan, if they physically hit you, or if they throw a projectile. Each Doom enemy has a different combination of behaviors within this quadrant diagram, discernible enough that they can be placed on a graph without overlapping. The visual characteristics, in particular here, the character silhouette, are different enough, and when they are similar, their behavior is very closely related in the graph. And this is another good example of how character design is not just about aesthetics, but has a profound impact on the design experience. The basic concept here is to make each element in the category as different as possible while still maintaining the core characteristics that permit that element to be identified as part of that category. The greater point here with this concept of orthogonal design is not just to have easily identifiable game components, but rather the clearer and to some extent broader gameplay that is created through this concept. By having vehicles that are orthogonally related, the player is not just having a clear silhouette to differentiate them with. He is also being provided a wider range of options on how to navigate the game level and the combinations of them. Maybe they do a portion by terrain, then they need to switch to water, and then they need to take to the skies to finish the level. The player is navigating the level, but how they navigate it is being articulated in a clear way. By having a different set of enemies, the challenge is not on remembering what enemy does what, or what the minute differences between 2 versions of the same enemy are, but rather the challenges focus on how to manage the resulting dynamics of the combination of all these different types of enemies or vehicles or any other type of category. It is still a challenge, but it is the right kind of challenge. That was a basic summary of the video. Now let's dive deeper into why orthogonal design matters and why it works from a game design standpoint, and we will finish up with some examples on how it is also applied in other design fields. The title of the video, if I haven't changed it, is Why Every Designer Should Understand That Orthogonal Design is Cognitive Design. Before diving into the design of cognition, let's first define cognition. Cognition is the amount of working memory being used to perform a task through mental process of knowing, including aspects such as awareness, perception, reasoning, memory, and judgment. But how is cognition different from psychology, you might be asking? The way I like to visualize cognition's place is between our brain and our psychology. The brain can be thought as the hardware. The operating system is the cognition that lets you run the software, the psychology. Psychology, the level at which we interpret the world, for example, where we give meaning to the color red as either rage or love, depending on its context, is where the vast majority of the focus from the design community is at. This leaves us with no real awareness of the difference between psychology and cognition, which in turn doesn't permit us to address design issues with the right tool set at the right level, either psychology or cognition. If you only have a hammer, everything looks like a nail. Once you understand this fundamental difference of the human brain and mind, and you start categorizing all the knowledge and insight of designers on how to design better, the majority of our collective knowledge and insight and focus is on the psychological level. The problem with this is that just as a software is limited to the capabilities of the operating system it is running on, the psychological interactions that we want to create as designers are also limited by the cognitive capabilities of the human brain and how we're handling those. Cognition facilitates the interactions, emotions, and overall experience we're trying to create as designers via the psychological level through our designs. How can we measure when we are doing a good or bad job as a designer at the cognitive level? When can we know that we have created that optimal and elegant interface between the human mind and the physical world? Well, we can't really measure it in a precise manner, but there is a way that we can know if we have succeeded in achieving every designer's goal, and that is through the concept of flow. Developed by Mihaly Csikszentmihalyi, flow defines the optimal human experience when 8 characteristics are present in that experience. These are complete concentration on the task, clarity of goals and reward in mind and immediate feedback, transformation of time, speeding up or slowing down, the experience is intrinsically rewarding, effortlessness and ease, there is a balance between challenge and skills, actions and awareness are merged, losing self-conscious rumination, and there is a feeling of control over the task. As he explains here, the best moments in our lives are not the passive, receptive, relaxing times. The best moments usually occur if a person's body or mind is stretched to its limits in a voluntary effort to accomplish something difficult and worthwhile. The flow state is maintained by a very careful balance of avoiding boredom and frustration. If the task is too easy and well within the person's capabilities, they find the task boring and therefore not engaging. If the task requires knowledge or abilities outside the user's current capacity, they find the experience frustrating and therefore not engaging. Neither state is good. What we need to do as designers is to facilitate the creation of this flow state in the user through our designs by providing a challenge that is at the edge of the user's capabilities, where if the user is fully engaged, they can successfully navigate the experience. But if they're not fully engaged, they fail. It's at this edge condition where users feel like they can master a worthy challenge to have a satisfactory, memorable experience. I have been working on a model for the last few years where I explore how exactly this balance can be achieved from a cognitive standpoint and derive principles and tools to help designers create a better cognitive layer in their designs. So I correlate the cognitive flow, this means the successful sequential navigation of designs, affordances, and signifiers of an experience with its flow state. In my framework, if cognition is not challenged enough, meaning, let's say, the memory game is too easy to remember, that means the cognitive requirement is too low, which means that the player becomes bored. On the other hand, if the cognitive requirements are too high, memory overload, the users get frustrated. It is achieving that balance of the correct amount of required cognition that will set the stage to generate the flow state. If we take these premises and apply them to the concept of orthogonal design, we can see why orthogonally related elements create a better user experience than slightly modifiable, similar looking elements. That is because it is fundamentally working at the cognitive level, and it requires more from the brain to remember subtleties rather than generalities. It's easier for us to quickly grasp and inventory the big categorical differences between elements more than their subtleties. And this might be because humans are meant to be generalists and not specialists. Let's quickly run through some examples. If I were to present you different set of angles to remember, which set do you think would be easier for you to recall? Set A with 0, 45, and 90 degree angles, set B with 27, 35, and 43 degree angles, or set C with 33.376, 33.599, and 33.035 degree angles. I wager it will be set A, because it is easier to identify, visual perception, easier to categorize, start, middle, and end, and easier to remember. Not much information is needed to differentiate them. This relates back to the example of the types of vehicles and their stats. The closer they are, the more minute the differentiators are, which are harder to perceive and remember, versus the further they are from each other, the easier it is to perceive them and identify them, helping with the recall mechanism, which permits users to deploy more of our limited human cognitive capabilities towards playing the game, mechanically exploring the game, and interpreting the stories and drawing meaning out of the game, rather than fumbling through the fundamentals of the human-object interactions and feeling no real cognitive ergonomic consideration in the design. In the GDC talk that was referenced in the video by Steve, it is explored why making meaningful choices is important for us humans, specifically in game design. In the video, it is stated that humans feel like they are making meaningful choices when they achieve competence, autonomy, or relateness. Interactivity is the cornerstone differentiating factor for the medium of game design. But interactivity by itself is not enough. It is a vehicle, a medium in itself, to create the opportunity for meaningful choices. And when this premise is missed in games, it is one of the most noted and hated failures of a game. For example, narrative options in a game that make you feel that through your game choices, you are affecting the final outcome of the game, to realize that all your choices lead to the same ending. When this happens, players do not like it because they feel they had no meaningful choices in reality. So, interactivity by itself is not enough, and neither is the illusion of choice through interactivity. And this makes sense as they were not really able to achieve genuine competence, autonomy, or relateness in this scenario. Now, to the greater point of this video. If the layer in which the user has to operate in to be able to achieve these attributes of competence, autonomy, or relateness is itself inhibiting their navigation and challenging the user to successfully operate the design to be able to achieve those meaningful choices, the design has failed. It is broken at a fundamental level, a level that is seldom recognized, let alone understood. And this is why designers need to be extremely careful and understand the cognitive requirements their designs are imposing on their users. And while at the psychological level is where the epiphanies and catharses happen, at the cognitive level is where the users navigate the designs in a way that will permit that psychological level to even come into play and unfold in the user experience. And not just in game design. We can see these in all the design fields. For example, in architecture, if I can't figure out how to open the door, I will never be able to experience going through this portal and experiencing the expansion and contraction of the space and all of its beauty. In product design, if I can't perceive the differences between all the buttons, I will never be able to experience the frictionless use of a device. If I can't clearly perceive the color differences of all the graphical elements in a website, I will never be able to identify all of its components to be able to navigate it. For me, this realization of the key role that cognition has in a design coupled with a lack of clear differentiation from its psychology counterpart in the design field, has made me go into a rabbit hole to further understand its unique role in design and how it should be addressed differently. That is why I have been working on a framework to be able to define and address this level of design more clearly and efficiently. And I have been able to discover quite a few very useful tools that permit me to visualize, understand, and manipulate my designs with a deeper understanding than what I had before, which has validated, for me at least, the importance of focusing and understanding how to properly design for the cognitive level. I wanted to end the video with a few book recommendations. Steve recommended the book 101 Things I Learned in Architecture School, which is a very, very good book to have. And I just wanted to add a few more books to the list just in case anyone is interested in this overall cognitive design topic. First off is Mihaly Csikszentmihalyi's book, The Flow, The Psychology of Optimal Experience, where he breaks in more detail the characteristics of the anatomy of the flow state. The second one is The Design of Everyday Things by Don Norman. Here he dives deep into how we operate designs. He really focuses on the exploration of when and why some designs works and others don't through something he calls signifiers. The next one is also from Don Norman, and it's called The Emotional Design, Why We Love or Hate Everyday Things. Here, he explores how a design can operate at different levels, specifically the visceral, behavioral, and reflective levels. Next is The Ecological Approach to Visual Perception by James J. Gibson, where he explores how we perceive and interact with objects and our environment through something he calls affordances. And finally, The Paradox of Choice, Why More is Less by Barry Schwartz, which goes into how the amount of choices given in a design affect the overall human experience, which I think is very fitting in this particular topic of orthogonal design. With that said, we have arrived at the end of the video. Thank you so much for watching the video till the end. If you're new to my videos, welcome. My name is Simon, and on this channel, I strive to give non-designers a window into the design world, and for fellow designers out there, I offer a wider view of the design world. Here, we talk everything design: architecture, game design, product design, design theory, philosophy, lifestyle, amongst many other topics. In the video description below, you can find a few of my other videos that I think you will like, so make sure to check those out. If you have any comments, questions, or insights on anything that was discussed here, make sure to leave a comment down below. With that said, thank you for watching this video, and I will see you in the next one.